All right, let's look at some homework problems from the book. We're going to be doing some problems that look a little different from the ones I did in the videos. The videos are pretty straightforward problems. These ones are a little weirder problems that still let us use the same information. Like number 3, for example. Fill in the table. So what do you think the derivative of 3 times the function should be? We're going to have to use our constant multiple rule. The derivative of some number times a function is just that number times the derivative of the function. So what that looks like here is that this thing up here really boils down to 3 times f prime of x from the constant multiple rule. So what is 3 times f prime? Well, f prime is right here. So just multiply this column by 3. That's 3 times f prime. We're going to get -6, -3, and 6. Great. Now, what are we doing for this column? Well, the sum rule and the constant multiple rule tell us that this is going to be 2 times f prime plus g prime. So everything here, just double f prime and add g prime. Double this, then add this. What that looks like is -4 plus 3, -2 plus 0, and 4 plus 1. Doubling this, adding this. And we're going to get -1, -2, and 5 for those values. And so similarly at this point, I think you know what to expect for this guy, right? This is going to be 3 times g prime of x minus f prime. 3 times g prime, it's going to be 9, 0, and 3. And then we subtract f prime, subtract a -2, subtract a -1, subtract a 2. So that's adding 2, adding 1, and subtracting 2. And we'll get 11, 1, and 1 for this column. This is just really getting you to use the sum rule, the constant multiple rule, with some calculus notation is the point of this one. That's what number 3 is going to look like. We're not going to do number 7 yet. We'll do that at the end of this entire long section of 2.5. But we're going to do number 8 right now. Use the information in the graph to plot the values of the function as below. So let's get a graph. Okay. We're going to need to plot some stuff. So let's say our graph starts here. I don't know how big or small we're going to need to go. So we're only going to need to go 1, 2, 3, right? Okay, so we need to plot the values of 2f. Oh, we need 3 graphs here. So let's start with 2f. Okay. So we know that 2f is just going to be double f. So if f is over here, it goes up to like 4 or something. We need to go up to double that. All right, we don't have room for that here. Let's do 2f over here. Okay. We get 1, 2, 3. We know 2f is just going to be double f. So if f is 3, 2f will be 6 here. 1, 2, 3, 4, 5, 6. This is where 2f is. And then about 2/3 of the way, it's going to go all the way up to 8, like here. And then it comes back to 6. And then it goes all the way down to 1 here. We need to double that. So it's going to go all the way down to 2. And then it goes back up to 4. And it should have the same shape, right? 2f should have the same shape as the original graph. It's just doubled. It's just stretched. This is 2f. What about its slope function? That's going to be a little harder. It actually only wants it at 3 points. We don't need the full graph here. It only wants it at 3 points. When x is equal to 1, what's our slope, do you think? Well, the slope of this original graph looks something like, I don't know, the slope is maybe -3. Right? It goes down 3, right 1. So maybe f prime right here. What we could do is we could say f prime of 1 is -3. So what is the value of the derivative of 2f? In other words, what is the derivative of 2f? Well, we know the derivative of 2f, because of the constant multiple rule, is 2 times f prime. So if that's the slope of f, what's the slope of 2f? Double that, -6. All right. So we're going to get at 1, the slope is -6. We're going to have to go all the way over here. Maybe we should count for us. 1, 2, 3, 4, 5. This is 5 up here. 1, 2, 3, 4, 5. This is -5 down here. Slope at 1 of the function, of the derivative 2f, is going to be -6. Slope of 2f. So we say the slope of 2f should be -6 right here. Does the slope of this graph look like -6? Yeah. You actually write the tangent line and calculate this tangent line, you should get visually something that looks like about -6. And we just keep on going in this manner. So at 2, we have a horizontal tangent line. F prime at 2 is 0. So what's the slope of 2f? Double that. Double 0 is 0. So at 2, the slope is 0. Is that consistent with what we think? Is the slope of 2f, which is this red graph, is that slope 0? Yeah, looks like it. Finally, what's the slope at 3? Slope looks to be about +1. So we're going to say that f prime of 3 looks like +1. So what's the slope of 2f? 2 times f prime, 2 times 1. Slope should be 2 here. And again, visually, if you did look at this and calculated the slope, you should get something close to 2. So we've now done the first thing it asks. We've graphed 2f. We've graphed 3 points for the slope of 2f. We've seen how they interacted with each other. The rest of this problem is now doing the same thing for f minus g and g over f. So you should have 3 graphs as your answer here. I'm not going to do all 3 of them for time purposes, but it's good practice for you. To get you started, the second one, we need to find the slope of and the original function values for f minus g. So to find the function values, to plot the red graph over here, you just take the blue minus the red, f minus g. To find their slopes, you find each of their individual slopes and subtract them, like so. And then for the last one is g over f. So the slope of g over f is low d high minus high d low square the bottom, and away we go. You'll do that for the last one as well. And now we've really done most of the hard part, right? We already have these three values. These are going to be really useful. We can reuse those. We'll find the three values over here, reuse those, and get all of these. Let me know if you have questions about that one. Looking at number 9. Use the graphs to estimate. We haven't talked about that yet. No, we should be doing 19 next, not number 9. That's why. Okay, let me pull it up real quick. Not where it is. Looking at number 19 is find the derivative. So we're not doing this at all. Find the derivative of x cubed plus 3x squared plus 3x minus 1. Oh, this is our function. And we want to find f prime of 1 and determine when is f prime of x equal to 0? When is there a horizontal tangent line? So we're going to do that, and we're going to compare graphically and see what we got. This makes more sense now. So to find f prime of 1, first we have to find the derivative anywhere, and then we'll plug in 1. We use the power rule for that, 3x squared plus 6x plus 3. Remember, the derivative of a line is just its slope. So the derivative of this red piece is just 3. That's our slope function. So what is f prime of 1? That's just plugging 1 into our slope function. Which, when we get it all out, this becomes a 3 plus a 6 plus a 3. And we get that the slope here is 12. We also need to find out, when is the slope function equal to 0? When does the graph have a horizontal tangent line? Well, the slope function equals 0 when this whole thing equals 0. We solve this by factoring or using the quadratic formula. To make factoring easier, we can pull out a greatest common factor, which in this case is 3. Remember to do some factoring review if this is a little unfamiliar, or you could ask me for some factoring review and I can point you in the right direction. And now we can factor it some more. There will be an x and an x. We need two numbers that multiply to 1, that add to 2. We'll get this. It's a perfect square. The solution to this equation is when x equals -1. We have a horizontal tangent line when x is equal to -1. Let's check our answers with Desmos. X cubed plus 3x squared plus 3x minus 1. So we said when x is equal to 1, when x is equal to 1, I guess that's the point 1 comma 6. When x is equal to 1, we said the slope was positive 12. Positive slope and pretty darn steep. Visually, we can see, yeah, right here at this orange point, positive slope, very steep. We also said there's a horizontal tangent line when x is -1. And yeah, it does look like at -1 at this green point, it looks like there's a horizontal tangent line. Great. Looks like we did it right. Let me know if you have any questions on this. Again, this algebra right here is probably a little unfamiliar. You may be out of practice with factoring. Good idea to review. It won't be super duper important though. Take it easy. Until next time.